Hi everyone and welcome to today's session of DBA Fundamentals. Now unfortunately due to a technical issue and a couple of work restrictions we're not able to show you the intro slides for DBA Fundamentals. We will show them after the session, which Andrew will kindly take us through. Today we have Andrew Prusky going over SQL Server and Kubernetes, and this will be the shortest intro that we have because Andrew's going to take it away now.
Thank you very much, and welcome everyone to this session on SQL Server and Kubernetes. A little bit about myself first. My name is Andrew Prusky. I'm a SQL Server DBA and Microsoft Data Platform MVP, originally from Swansea, Wales, but I've been living in Dublin, Ireland for about 6 years now. On the screen there are my contact details at dbafromthecold and dbafromthecold@gmail.com. So if you have any questions after today, please feel free to reach out. I'm always willing to talk about this stuff. I'm also on the SQL community Slack channel. There's a Kubernetes channel there. So if you have any questions, post them in there. I'll tend to pick them up as they come in. My blog's there as well, dbafromthecold.com. Posted multiple articles about running SQL Server in containers and Kubernetes, some of which I'm using to base this session on, and some of which go into a little bit further information. So you're welcome to check that out. And then finally, at the bottom there is my GitHub account. All the code for the demos I'll be doing and the slides for today are on my GitHub, and I will post a link for those at the end as well. So, on to the session. The aim of this session is to give you background knowledge and some code so that you can go away and start getting involved with running SQL Server on Kubernetes. Kubernetes is really a hot topic in tech at the moment. Microsoft are embracing it as well. So having some knowledge about this technology, I feel for us as SQL Server folks is really beneficial. So we'll go through the definition of Kubernetes, a little bit of history about it, how we can get up and running locally. We're using Docker for desktop and enabling Kubernetes in there. Then we'll have a look at using declarative deployments for Kubernetes, bit of persisting data, and then at the end we'll have a look at a package manager for Kubernetes. And then to round the session off, we'll have a look at some chaos engineering tools. But first things first, what is Kubernetes? Now, the definition there is from the kubernetes.io website. And it says that Kubernetes is an open source platform for managing and deploying containerized applications. Okay, so what about Docker? Isn't Docker a platform that we can use to deploy and manage containerized applications? What's the difference there? Well, with Docker, we install on a host and we run our containers, but we only install that one host. That is a single point of failure. With Kubernetes, we have the option of having a fleet of hosts where we can run our containers. And we don't typically say to Kubernetes, I want to run on that host or I want to run on that host. We just say to Kubernetes, I want to deploy this, throw it into Kubernetes and allow it to work out everything in the background. It abstracts that infrastructure away from us. So a little bit of history about Kubernetes. Kubernetes, it's a Greek word. It means helmsman or pilot. And I always mention that because it explains the logo. So it originally came out of Google. It came out of Google's Borg system. And if you've read the Google's Site Reliability Engineering book, they go into quite a lot of detail about their Borg system. But Kubernetes came from that Borg system. Even so, its nickname, whilst it was being developed, was 7 of 9. A friendlier Borg. It's also why there are 7 spokes on the wheel there, apparently. So originally designed by Google, it is now hosted by the Cloud Native Computing Foundation, and version 1.0 was released in July 2015, so just over 4 years old. Okay, so that's what it is. That's a little bit of history about it. But the main question I always get asked when it comes to Kubernetes, especially running SQL Server on Kubernetes, is why? Why do I want to run SQL Server on Kubernetes? Think about all the different platforms that we have for running SQL Server. We have physical machines, we have virtual machines in our private data center or up in the cloud. We have Azure SQL DB, we have Amazon's RDS, we even have managed instances in Azure. So why do I want to run SQL Server on Kubernetes? So let me tell you a story. A couple of jobs ago, I was working with a QA department and they were having issues refreshing their dev environments. Now, their dev environments were VMs with the full production stack on them, each one requiring an instance of SQL Server. SQL was installed via Chocolatey, and then the dev databases were restored via a series of PowerShell scripts. Now, unfortunately, this wasn't the most reliable process in the world. It was prone to failure, and it wasn't the quickest either. We're talking anywhere between 40 to 60 minutes just to get SQL installed and then these databases restored. So we decided to get rid of all the local instances of SQL Server on those VMs and move them to SQL running in containers on a remote host. And a few bumps in the road, but eventually it got working an absolute treat. The longest it took us to get a new instance of SQL Server up and running, fully configured, with all those databases ready to go was 2 minutes, down from 40 to 60 per VM. So whichever way you look at that, that is a huge saving. And it works so well, I was sitting there one day and I was going, this works really well. I don't really want to be installing SQL and configuring it anymore, even though we have some great tools to do that. Spinning up in containers fully configured really looks like the way to go. Can I do this in production? Can I run SQL Server in a container in production? And the longer I thought about it, the more the answer was glaringly obvious. And that answer was no. The reason being, I've mentioned this earlier, we were running SQL Server in containers on one host. There's a single point of failure. What happens if that host goes down? And it did go down one day. We came in, host was down. QA department couldn't do any work because none of their SQL instances were online. Also, we found when we got towards between 40 to 50 containers, it did become slightly difficult to manage them. So the containers are up and running, but is SQL within them up running and is it healthy? If the container does have a problem with SQL in it, is it going to automatically restart? If it does, how are we going to persist any data that we've changed since the container has spun up? All these issues prevented us from going to production with SQL Server in containers. This is where orchestrators come in. Orchestrators give us the tools to overcome these challenges. They give us the ability to have multiple hosts where we can run our containers, and they allow us to perform health checks within our containers as well. So if the application within it has a problem, the container automatically restarts, and we get tools for managing and persisting our data as well. So why learn Kubernetes? It is the leading orchestrator out there on the market. It is doing so well, in fact, the competitors have started incorporating it into their platform. Docker Enterprise, even though they've sold it off now, did have the ability to incorporate Kubernetes into that platform. You can run Kubernetes in Docker Enterprise. And you can see when I'm running Docker Desktop later, there's a little tick box where I can enable a one-node Kubernetes cluster. So Kubernetes is the leading orchestrator out there. It gives us great tools to easily spin up containers. We have high availability built in. And if you are looking at SQL Server 2019 big data clusters, Kubernetes is the technology that's built upon. So if you're learning big data clusters, highly recommend you learn a little bit about Kubernetes. Okay, so let's get started and let's have a look at deploying SQL Server to Kubernetes. And the best way to do that is run it locally. So we have a couple of options here. We have Minikube. If you check out the Database Avenger, James Anderson's blog, he has a great article on getting SQL Server running on a Kubernetes in Minikube. I've mentioned previously, we have Docker for desktop. This is what I'll be running my demos on. There's a little tick box in the Docker settings, and that will pull down all the components required for running a local Kubernetes cluster. And then the other one there is MicroK8. So if you're running on a Linux laptop, highly recommend MicroK8. Does exactly the same thing as Docker for desktop, allows you to run a one-node cluster locally on your machine. Other tools that we can use, Visual Studio Code and Azure Data Studio, both have great plugins for Kubernetes and Docker, so you can explore your local instances with a nice GUI tool. And then we have kube control there as well. This is the main command line tool that we use to interact and deploy to Kubernetes. But let's go ahead and let's have a demo of getting SQL Server up and running in Kubernetes. So this is my Azure Data Studio locally here. And the first thing we need an image to run our containers from. Now, this used to be really simple when Microsoft hosted their images on the Docker Hub. We could do Docker search MS SQL and see the image that we wanted. We could even go online and type into the Docker Hub in their web GUI and see the images there. Microsoft have since moved their images to their own private registry called the Microsoft Container Registry, so we can't do Docker search and we can't go online, but what we can do is do an invoke web request to this address, and then we can list out all the different images within that repo. And these are all the SQL Server images, all the 2017 ones, all the 2019 ones, the CPTs, the RC1, and then the GA release there. And I'm going to go with the RC1-Ubuntu image. So if I check my local machine, oh, hello Docker, there we go. So I have all the Kubernetes components here because I've enabled Kubernetes, but here is my image, 2019 RC1-Ubuntu image. So what I'm doing here is just checking I'm pointing at the right cluster, and I'm not. So I'm going to point to my Docker desktop cluster. There we go. I can confirm the nodes in my cluster by doing kube control get nodes. And there we are. I just have a one node Kubernetes cluster running locally on my machine. So let's go ahead and let's deploy. This should look vaguely familiar to anyone who's run SQL Server in a container. Instead of saying Docker run, I'm saying kube control run, a deployment called SQL Server from my image. And then I'm accepting the end user license agreement and setting an SA password so I can connect. So hit that. And there we go. There we go. And I can view that deployment. So ready, up to date and available, all ones, looks good. I can check out something called a pod. We will talk about these concepts later, but just for now, there we go. There's SQL Server running in my pod. And I can do something like grabbing the pod's name, doing a kube control exec, which is similar to a Docker exec. So I can jump in to the pod, navigate to where SQL command lives, connect, and then run a SQL command against the instance. And there we are, Microsoft 2019 RC1 running on my local Kubernetes cluster. Okay, so it's up and running, but that's not particularly great. I don't have to be running kube control exec, navigating to where SQL command lives, and then running my queries. What I want to be able to do is connect like a normal instance of SQL through Azure Data Studio or Management Studio. So what I can do here is something called expose that deployment. So I can say kube control expose my deployment SQL Server, a type of load balancer, and we'll discuss types of services later in the session. But this is the main point here. I'm opening up port 1433 to port 1433, the default port that SQL listens on. And by doing this, what this will do in Docker Desktop, eventually, there we go, is expose that SQL instance on localhost port 1433. So what I can do now is jump in with Azure Data Studio, connect my localhost, hit manage, and here is my local instance. I can run a query, select ATAT version, and there we are. We're connected via Azure Data Studio, or if we want Management Studio, into SQL Server running on our Kubernetes cluster locally. So if I close this down, there we go. And let's just do a little tidy up. There we go. Oh, typing in demos, there we go. Okay. So we have deployed using 2 commands and got our SQL instance up and running, and we can connect to it locally. Now we have a one node Kubernetes cluster running on our laptops, but that's not really how Kubernetes works out in the wild. You will have a cluster with more than one node on it, and there are 2 different types of nodes, starting with the master node. Now, the master node is what holds all the components for controlling and managing the cluster. So it has things like the Kube API server. This exposes the Kubernetes API and processes REST operations. Everything in Kubernetes is represented by a RESTful resource. We call them the Kubernetes objects. They live in the cluster store, and each one of those objects has a unique HTTP path. When we run a kube control command, we are actually making a GET request to those URLs so we can pull down information about the objects that live at that location. So when I say kube control get pods, I'm making a GET request to the URL that the pods live at, and I pull down the information about the pods that are running on my cluster. I mentioned the cluster store. The most widely used technology is etcd, a distributed key value store. And this just holds information about the objects that are in our cluster. Next component is the kube scheduler. This is what decides which node we deploy, the pods that we deploy run on. And this is based on various different algorithms, main one being things like node resources consumed. The next one is the controller manager. This manages controllers in Kubernetes, and controllers are responsible for things like responding if a node goes down, making sure the correct number of pods are running in the system, and mapping services to pods. And the final one is the cloud controller manager. This is what hooks Kubernetes into the underlying cloud provider if we're running in the cloud, giving Kubernetes access to that cloud provider's resources. So we'll see this a little bit later. If we deploy a service with a type of load balancer, say we deploy in Azure, the cloud controller manager will hit Azure saying, hey, we need a load balancer for this service. Please spin up a load balancer so we can get its IP. So that's the master controlling our cluster. But we don't deploy our pods to the master. We deploy them to the second type of node, which is the worker node, responsible for running and maintaining our pods. And this contains things like the kubelet. The kubelet takes a pod spec from the API server and ensures that all pods in that pod spec are running and are in a healthy state. The next one is the kube proxy. This enables service abstraction by maintaining networking rules and connection forwarding, and we'll cover services in a little bit. And then finally, we have our container runtime. This is what's actually spinning up our containers. And mostly used is Docker, or there are other options out there now. So we have our master controlling our cluster. We have our worker nodes where we deploy our pods and pods. I keep saying that word, pods. What is a pod? The way I remember what a pod is to think what the image for Docker is. And the image of Docker is a whale. A group of whales is a pod. And that's what a pod is. A pod is a group of one or more containers. And they are the smallest deployable units of computing within Kubernetes. So we don't deploy containers themselves. We deploy pods, and within those pods are our containers. And they share storage and network. So the pod's exposed on one IP address, and then the different containers within them live on different ports. So we have our master controlling our cluster. We have our worker nodes where we deploy our pods, and within our pods are our containers. Now, in Kubernetes, pods are mortal. They die and are reborn. And when they are reborn, they come up within the cluster with a different IP address. So that means if we connect directly to the pods via their IP address, it dies and comes back up with a different one, we're going to lose our connection. This is where services come into play. Services provide a layer of abstraction over a set of pods, one or more pods, and give us a stable networking endpoint. So we don't connect directly to our pods, we connect to a service, and the service routes our connection through to our pods so that we can connect. And there are different types of service. We have cluster IP. The service will get an IP address that is only accessible from within our cluster. Node port. The service is exposed on the same port on all the different nodes in the cluster. So we use a node IP, and that port we connect to the service. Then there's load balancer, mentioned just a minute ago. This will, in say Azure, go off, hit Azure and say, hey, I need a load balancer for this service. Load balancer will give us an IP address that we can use to connect to our service from outside the cluster. And then finally, we have external name, where we can map our service to a DNS entry. Okay, so we have our master controlling our cluster. We have our worker nodes where we deploy our pods that contain our containers, and then we have our services that we use to connect to our pods. Now, in the first demo, I used an imperative method to deploy SQL Server. I told Kubernetes what I wanted and how I wanted to do it. I said, kube control run from this image with these environment variables. But that's not the only way we can deploy to Kubernetes. We can use a declarative method to deploy. We can use a config file, say like a YAML file here, and push that into Kubernetes, and Kubernetes can work out what we want to be deployed by reading that YAML file. So here is an example YAML file, starting off with kind of deployment, type of deployment, and then we're going to start with some metadata. I'm going to give my deployment a name, and I'm going to call it SQL Server. Then I'm specifying the number of replicas. What I'm doing here is saying I want at any one time running one pod running in this deployment. Kubernetes has a concept of desired state versus running state. I am defining my deployment's desired state in this YAML file. And when I deploy it into Kubernetes, it then becomes my running state. And Kubernetes constantly checks between the two to see if there are any differences. If there are any differences, Kubernetes will automatically fix those for me. So if anything happens to this one pod, Kubernetes will automatically spin me up a new one. So we want one pod. Let's go ahead and let's define what we want running in our pod. So we're going to spec out the container that we're going to run in that pod. Starting off with a name, I'm going to call it SQL Server 1. Terrible at naming things, but there we go. From an image, I'm going to again use the 2019 RC1-Ubuntu image. Open up a port on the pod, port 1433, default port that SQL listens on, and then specifying my environment variables. So my SA password and accepting the end user license agreement. So there we are, we've configured our deployment and the containers within our pods. But remember, we're not going to connect to our pod directly. We're going to connect to a service, so we need to spec out our service as well. So we are saying kind service, type service, and then giving our service a name. I'm just going to call this SQL Server-service. Then I'm mapping some ports. And what I'm saying here is that anything that hits my service on port 1433 automatically route that connection through to my pods, hit that pod on port 1433, then I'll be able to connect to SQL Server. Then I'm using a selector, name SQL Server. This is how I'm mapping my service to my pod. And then finally, specifying a type of load balancer. And this, when you run in Azure, you'll get an external IP. When you run it in Docker for desktop, it will expose your service like we saw in the first demo on localhost, and you can use that to connect. So let's go ahead and let's use a declarative method to deploy to our local Kubernetes cluster. So if I disconnect here and close that, don't save. Make sure I'm in the right cluster. There we go. Set the migration, and then here's my YAML file. Pretty much exactly the same. In fact, it is exactly the same as the one in the slides. So one pod with my labels and my RC1 Ubuntu image, my environment variables, and then here's my service with a type of load balancer, port 1433 to port 1433. So let's go ahead and let's deploy that to the cluster. Now, I'm not saying run. I'm not using an imperative method. I'm using a declarative method. So I'm just saying kube control, apply whatever is in this file to the cluster. And Kubernetes will look through the file, work out what's in there, and then deploy my service and my deployment. So let's check out what's happened here. We can say get deployment. my SQL Server deployment ready, up to date and available, all of ones. Let's check my pod. There we go, one pod, SQL Server up and running. And I can get some more info on my pods by saying kube control get pods dash output wide. And I can see the IP address internally that my pod has within my cluster. I'll do a clear there. I can also do a describe on the pods. I can see the events that have happened when I deployed. There we go. If you look down the bottom here, we can see the scheduler kicking in and deciding where my pod is going to live. Now, it doesn't have much of a choice because this is a one node cluster, but we can see it there. And then we can see the kubelet kicking in saying, container image is already present on my machine. If I didn't have the RC1-Ubuntu image already downloaded, it would go off and it would pull that image down for me. Then it's created a container and then finally started the container. Okay. Let's have a look. We've got the Git service. And there we are. We are able to connect on localhost. So I can jump back in here, click manage, and I'm connected into my instance, get rid of that. And then let's open up, let's do something with this instance of SQL Server. Let's create a database. So I've got a notebook here, and let's confirm the version. Oh, I know why that's not working. Close that. Let's connect to the correct instance of SQL Server. Oh, hello. There we go. Microsoft SQL Server 2019 RC1. Okay, let's go ahead and let's create a database. Not doing anything special. Let's check where those files are. There we go. So we've created a database. Didn't say it, took all the defaults, and that's created on var opt MS SQL data. Now this is the default location for SQL Server databases for SQL running on Linux. And then, I don't know, let's just create a test table and put 200 rows in. Nope, go away. There we go. So I can close that. And then what's happened here? Get rid of that. There we go. There is my test database. Okay, so let's jump back into the code. Let's have a look at our pods. There we are. There's our pod running, IP address of 10.1021. Now what I'm going to do is grab that pod's name and delete that pod. Now what's happening here is that the running state no longer matches the desired state. Remember in the YAML file I configured, I said I always wanted one replica, one pod SQL Server running at all times for this deployment. So Kubernetes has realized that the running state no longer matches the desired state, and hopefully has created a new pod for me. And there we are, running age of 25 seconds, and there's our IP address, 10.1.0.22. It's come up with a different IP address in the cluster. But I don't mind because I still have my service exposed on localhost. So I can come back here, get rid of this, and I can do a refresh. And I'm connected, but I've lost my test database. The reason that has happened is because that test database was created after my initial container was created from the 2019 RC1 image. So when I blew that pod away, Kubernetes went, the running state no longer matches the desired state. I'll create a new pod for you, and I'll create it from the 2019 image, but it doesn't have any knowledge of that database. So that database is gone. And when I say gone, I really mean gone. We can't get that database back. And for me, as a SQL Server DBA, I find that quite terrifying. So we need to go ahead and we need to look at persisting data for our SQL Server instance running in Kubernetes. Okay, so We're going to have a look at persisting our data now for SQL Server running in Kubernetes so that we won't lose databases like that, because Kubernetes has the same issue as Docker containers. Data changes that are not on some form of persisted volume will be lost when our pods restart due to some issue, or if they migrated nodes or such. So the way we do that is by something called a persistent volume. Now, a persistent volume is just a piece of storage in the cluster. It could be anything. It could be an Azure disk, absolutely anything, as long as the cluster has access to it. The key point here is that its lifecycle will be independent of any pods in the cluster. So those pods can go up, come down, go up, come down as much as we want. We still have our data on our persisted volume. And the final point there on the slide is that we can either statically provision persistent volumes, we can create the volumes ourselves, or we can let Kubernetes dynamically create them for us. And that's what I'm going to show you in the demo in a couple of minutes. Another concept we have to consider with persisting our data for SQL Server in Kubernetes is something called a persistent volume claim. Now, a persistent volume claim is just a request for storage by a user, such as myself. And I request things like size and access type. So I say how many gigs I want and say read write once. That means only one node at a time can write to my volume, which for a SQL Server instance is pretty much the way I want to go. And then we reference the persistent volume claim in our pod spec, and we don't reference the persistent volume. So the pods use the persistent volume claim, which then attaches the persistent volume. Okay. Now I mentioned we can create persistent volumes dynamically, and the way to do that is via something called a storage class. Now, a storage class is just a type of storage that we have access to within our cluster. So in the example here, I'm setting this up in AKS, Azure Kubernetes Service. So I'm saying I want a storage class with the name of Azure Disk, using the Kubernetes plugin for Azure Disk, and then setting some parameters of standard local redundant storage and a kind of managed. Now, once I have that storage class, I can reference it when I create my persistent volume claim. So when I create my persistent volume claim here, type of persistent volume claim, metadata, name, MS SQL data, access mode, read write once, and then I reference my storage class name. And that's the one I've just created, Azure Disk. Once I reference that, I then reference how much storage I want. I'm going to go with 1 gig here because it's a demo. If I went with longer, we'd be waiting longer for these things to spin up. But 1 gig comes up fairly quickly. And then that will create my persistent volume in the background for me. So I don't need to manually go ahead and start creating volumes that I can attach to my cluster. This will all happen magically in the background. Okay. Now, one thing I do want to mention is, I don't know if anyone noticed in the first demo, in my config file, I had hard-coded my SA password into that YAML file. Now, this is a bad thing. I don't really want to be having my SA password in clear text floating around in config files that I'm going to do something like push up to GitHub. So Kubernetes has an option here called secrets. We can create a secret that will hide away our sensitive data. So I can say kube control, create secret, a generic MS SQL from literal, and it's going to be SA password. And this is the key value here. So SA password is the key, and the value is testing 1122. And then instead of referencing my SA password directly in my YAML file, I can then say value from secret key ref, the name of the key and the value. Sorry, the name and then the key. And that is a lot better than having my password in clear text in a config file. However, there is a major gotcha with this, which I will show you in the demos. But it's better than having testing 1122 in there. And now I can attach my volume. So I can say volume mount, so I'm going to call it MS SQL DB, and I'm going to mount it at var opt MS SQL, one directory above where the default location for SQL Server databases live on Linux. Remember, it was var opt MS SQL /data. And then I reference my persistent volume claim. And this will attach my persisted volume to my pod, and we will be able to persist our data. So let's go ahead and let's persist our data for SQL Server running on our local Kubernetes cluster. Close that. Here we go. Now I'm definitely in Docker for Desktop just to make sure. There we go. And I'll set my location to where my YAML files live. And then first thing, let's have a look at that storage class I'm going to create. Now I'm not running in AKS, so I'm going to run in a little bit different, running in Docker, really simple YAML file kind type storage class. Going to give it a name of test-storage class. And then the provisioner is docker.io and host path. So this is what I need to reference to be able to dynamically create persisted volumes for this cluster. If I clear that, I go ahead and create my storage class. Kube control apply, take my config file, work out what's in it, and deploy into the cluster. And I can view that storage class, get SC, and there we are at the bottom there, test SC. Now you'll notice it's exactly the same as the default one here. If I technically didn't have to create that storage class, I could reference the one that was already there. But the only reason I did is just to show you the process of stepping through, creating a storage class, and then creating a persisted volume claim referencing that storage class. So where's my persisted volume claim? There it is. Exactly the same as in the slides. The only difference here is I'm referencing this one, which is for Docker, not the one in the slides, which was Azure Disk. Let's go ahead and let's create that. There we go. Okay. So now I should be able to view my persisted volume claim. And there we go. Okay, so we have a name, MS SQL data, status of bound, which means it's already created my persisted volume in the background for me, capacity of 1 gig, access mode of read write once, and then referencing my storage class. So now that I've got my persisted volume claim up, I can see my persisted volume as well. And there it is. There's the name, dynamically generated, so it has this big long name, capacity of 1 gig, same access mode, reclaim policy of delete. Now what this means is that if I delete my persisted volume claim, it will also go ahead and delete my persisted volume. So I might want to change that to something like retain, so I can delete my persistent volume claim and it will keep my persistent volume. But this is a demo. I like to tidy up after myself. I'm going to leave it the way it is. And we can see it's bound, referencing our claim and our storage class. Let's also create our secret. So same as in the slides. And then get secrets. There we are. I can see, and I could try and be a little bit cute here and describe secret, see if I can get at that volume, like get out that data. I can't see it. But what I can do is if I come over to, just save that there. If I come over to the Kubernetes plugin for Visual Studio Code or Azure Data Studio, when this refreshes, I should be able to see my clusters here. Come on, there we go. Let's try a reload. Oh, for some reason, I can't seem to view my Kubernetes cluster in Azure Data Studio. But what you can, oh, hang on, we're going to get it? There we go, okay. We have our Docker desktop there, and I can come down, come to configuration, secrets, MS SQL, and there's my SA password, and boom, there is my value. Secrets within Kubernetes are encoded. They are not encrypted. So even though they are a good way of not having our passwords in clear text in config files, they are not as secure as you think they are. So just be aware of that. but I've got it there and don't use the integrated console. Let's go ahead and let's deploy SQL Server with our persistent volume claim. Oh, that's why I do this. There we go. There we go. Let's try that one more time. Excellent. So I've got my SQL Server deployment and my service. So I can get my deployment ready, up to date, and available. And let's view the pods. Pod is up and running as well, and we can get the service. Again, using a type of load balancer to expose on localhost. So I can jump in, click manage. And I should be able to connect. Can I get a new query? Oh, there we go. Laptop's being particularly slow for some reason. There we go, and I'm in. So let's do the same thing that we did in the first demo. Let's create a database, connect it to local, confirm my version to make sure I can run queries. There we go. SQL Server 2019 RC1. Let's create our database using the defaults again. Remember, it's var opt ms SQL data, and we mounted our persistent volume at var opt ms SQL. There we go. And then let's beware our slide. There we go. There's our database, var opt ms SQL data. And let's create a test table and insert 200 rows. Excellent stuff. Okay, let's save that. If I do a refresh, there's our database. Let's have a view of our pods. Let's just do that again. There we go. So this one's got an IP address of 10.1.0.23. Grab that pod name and let's delete it. So remember, now what's happened is the running state no longer matches the desired state. So Kubernetes should spin me up a new pod. And there we are, back up with 10.1.0.24 different IP address, but I should still have my connection. And if I do a refresh, my test database is still there. So I can jump into another notebook here, just to prove I'm not cheating, do a select start from named, and there's our database. Confirm the test tables there as well. And now we've got our 200 rows. There we go. So by using persistent volume claims and persistent volumes, we can retain our data changes from one pod to another.
Andrew,
yes.
Sorry to jump in here, but somebody has raised a question that's how does the master database keep getting retained if you're destroying and recreating the container?
So that's where if we come back into here, where are we? Come back here, and if I do use master, the master also lives in the location where we mounted our persistent volume. So we create our database. There's a record in the master database for our test database. We blew the pod away, but our master database was also retained. So when we attach that persistent volume to another pod, that master database was retained. It kept a record of our test database. SQL spun up and attached all of our user database, test database for us. So we're also retaining the master database.
That's perfect. Thanks, Andrew.
No problem. Okay, let's do a little bit of a tidy up here and get rid of all of this. And go. Okay, great stuff. All right, coming to the end of the session now, and the next thing I want to show you is something called a package manager for Kubernetes. Using declarative deployments is great, but you do have to manage YAML files. I'm yet to meet someone who really likes YAML. if you are working with Kubernetes, the nice thing about working in Visual Studio Code or ADS is the Kubernetes plugin will actually tell you of any formatting errors for your YAML file, say if you've used 3 spaces instead of 4. But what's really nice is that we have the option of using something called Helm in Kubernetes. And Helm is a package manager for Kubernetes. And there is a SQL Server package, or what we call in Helm is they're called charts, available in the Helm Hub, which is very similar to the Docker Hub. I'm not going to mess around too much, time's ticking on, so I'm going to jump straight back into the demos and let's deploy. Now, I'm not going to deploy to my local instance here. I'm going to deploy to an AKS instance because I don't have Helm installed locally. So I can confirm my Helm version using the keyword Helm, and I have a client and I have a server version. Now I'm on version 2. The version 3 has actually got rid of the server component for Helm, but for now, I'm still running with version 2. And I could do something like Helm search stable, which is the Helm Hub MS SQL Linux. If I do that, there we go. We have a SQL Server 2017 Linux Helm chart. And what's really cool with Helm is I can do a dry run and a debug. I can see exactly what will happen if I try and install this to my cluster. There we go. Found the chart. And we have a whole bunch of stuff coming out here. We have a load of persistent volume claims. We have our port being opened up. We come up, we have a load of environment variables set in the default data log and port and backup directions collation. And then if we go higher up, we can see this now defaults to 2017 CU5. Now you can pass in variables to change those figures, but I kind of like building my own stuff. So I went ahead and I built a Helm repo and a Helm chart for SQL Server 2019. Now this is just a little dev one. I wouldn't recommend you use this to deploy in any way, shape, or form in anger. Just messing around, absolutely. So I can do Helm search DBA from the cold SQL Server 2019 RC1. There it is. And then I can do a dry run. And then we can see we're going to run 2019. It defaults to the RC1 image. And then we have password with a secret, accepting the end user license agreement, enabling the agent, all that jazz. So let's go ahead and let's deploy that. Now, what I'm going to do is deploy this to my AKS cluster. So let's do Helm install, and off we go. Boom. And we can see the default values here. No persistent storage is configured for this. This is literally just for testing around with, and I don't set any resource limits either. So let's go ahead and let's have a look to see what's happening there. Let's clear that out. There we go. SQL Server 2019 deployed today. I can get my deployments. Side up to date and available. Get my pods up and running. And let's have a look at my service. There we go. Now you can see here that my external IP is pending. I've deployed this service with a type of load balancer into Azure Kubernetes service. So the Cloud Controller Manager has kicked off and gone, hey, I need a load balancer for this service. So if I describe my service, I can have a look at down here and it says ensuring my load balancer. So what this is doing is going off, hitting Azure and saying, hey, I need a load balancer for this service. Please spin up a load balancer so I can get its IP. This can take a couple of minutes even for it to spin up because it's actually creating external resources. Sometimes we get lucky, it's a little bit quicker. There we go. Okay, it's come up. So if I go describe service, we can see the service controller, which has a dependency on the Cloud Controller Manager for this service. It has ensuring and then ensured our load balancer. And I can grab the service IP, grab that, and let's see if I can jump in and connect. Let's just connect. There we go. And then we are connected to SQL Server running in an Azure Kubernetes service cluster exposed via a external IP provided by a service with a type of load balancer. I can do query and do select that version. Oh, there we go. And there we go, 2019 RC1, same as we've been using because that's the default image that's used in my Helm chart. Okay, so let's just do a little tidy up there, disconnect from there, and I can delete. 3, 2, 1. There we go. Okay, so that's Helm, a really, really useful tool for managing deployments to Kubernetes. Now then, let's finish off the session with a little bit of chaos engineering. Now, chaos engineering is the discipline of testing a system to see how it reacts to, say, turbulent conditions in an environment. Basically, what we're doing is testing a system to see if it responds as we think it will do when it encounters a failure. And a good thing for testing for SQL Server in Kubernetes is that desired state versus running state. So we should know that Kubernetes should go off and it should always keep the desired state matching the running state. And we've been doing that in the demos. We've been deleting pods and seeing them spin back up. But hey, I like the command line, I live in the command line. But what if we had a nice GUI for showing that functionality? And wouldn't it be great if that GUI was Space Invaders? Now, this is a project I found on GitHub. It's called Kube Invaders, and you can see that the invaders there are our pods, and we play the little spaceship. So not going to mess around here. Let's go ahead and let's demo this in action. So I'm going to open up Kube Invaders. I'm definitely connected into my AKS cluster. This all runs up in AKS. There we go. And what I'm going to do here is run a deployment with 10 instances of SQL Server running in it. So there we go. There's our deployment. I'm going to just double check they're out. Oh, they're coming up. And there we are. We have 10 instances of SQL Server running in this deployment. Now what I can do is grab this and then switch over. And there they are. And now I can play my game. So let's see if Kubernetes will deal with me killing these pods. And as we can see on the left there, the desired state no longer matches the running state when I'm destroying my pods. And we can see new pods being spun up by Kubernetes. And if I leave this a second, there we go. It is syncing back up. So I can continue going ahead and deleting these pods, watching Kubernetes redeploy them because the desired state, sorry, the running state no longer matches the desired state. And then I can switch it into automatic mode and let it play itself. We see those pods coming down, and hopefully we'll see it resync. There we go, and it's brought our 10 pods back. So we can let that run and we can see if Kubernetes can handle it, deleting our pods over and over and over. But I'm going to call that there and then just cancel that, come back, and then let's delete that. Okay, so finishing off the session, just got some resources for you. The top link here is the link to my GitHub account where I have all the code and the slides for this session. The second link down there is a link to my blog that has a summary of all the posts I've written about running SQL Server in containers and Kubernetes. And then the third link there is to the GitHub account where Kube Invaders resides, and I highly recommend you go and check that out. Do we have any questions?
Yes, we have some awesome questions.
Okay.
All right, so how do you handle individual database backups in containers?
You can do exactly the same as you would a normal instance of SQL Server. Back up your databases. Kubernetes is just another platform that we would run SQL Server on. You need to handle your backups exactly the same way as you would any other instance of SQL Server.
Awesome. Even easier than I expected on that one. Sweet. All right, so another question is, how do you monitor the SQL Server instance running in the pod? When we're having multiple pods running, e.g. one of the SQL Server instances consuming a high CPU?
Okay, so you can put resource limits on your pods so they can't take up all the resources on a node. So this is like the noisy neighbor situation where you have multiple pods running on node, one pod is taking up a load of resources, you can limit on the pod itself the amount of CPU and memory available to individual pods, and then obviously have your monitoring tools around it. So there's the Kubernetes dashboard, there's things like Prometheus and Grafana that you can deploy in to really drill down and find out what exactly is happening on your cluster.
All right. Can the max memory or any other SQL Server settings be passed in as parameters, or is that just a one-off, this is what you get?
I'm not sure if the max memory can be deployed via an environment variable, same as like accepting the end user license agreement and changing the port. If you Google SQL Server on Linux environment variables, it'll give you a big long list of the environment variables available to configure SQL. But off the top of my head, I'm not sure. But you can definitely set the max memory the same as you would any other SQL instance once it's up and running.
All right, so final question here. What happens to any running transactions when we delete the pod?
Exactly the same as any other instance of SQL Server. If a big long running transaction hits and that pod restarts, your database is going to come up and it's going to have to go through recovery, exactly the same as a normal instance of SQL. So yes, in the demos, I'm getting very lucky. The fact that there's nothing running there, I'm deleting it, it's coming straight back up. But yes, if I deleted it and there was something running against that, the database would go through recovery as it normally would. It's restarting an instance of SQL Server, basically.
Perfect. All right, so Andrew, thank you very much. I actually learned a lot about Kubernetes and how it's deployed and how it all works there. So I do thank you very much, and I'm sure everybody that attended our session actually learned as much as I did, hopefully. Hopefully I learned more than just the Alien Invaders section.
No, I really like demoing that. It's good fun.
Yeah, that's probably the most fun part you can have.
No, thank you very much for having me.
Oh, thank you. All right, so now since we did not have the actual introductions slides to start with, we're going to do a quick version of that here at the end. So thank you, Andrew, very much. And I will flip over to using mine, hopefully. All right. So as you have just heard, this was SQL Server Kubernetes with Andrew Prisky on today's date. Then there's on the right-hand side of the screen, you'll see the number of presenters, the organizers who actually organize the presentation. It's Steve Cantrell, Shane O'Neill, Warwick Rudd, Kevin Wilkie, which is me, then Glenda Gable also helps. We run this every month, every week that we have presentations. We can always reach us, this is the easiest ways, one of the easiest ways to reach us via our own Twitter handles, or you can always link up with us on dbafund.org, our YouTube channel, the Twitter channel for DBA Fundamentals, on Slack, where there is always some fun meeting going on. You can also hit us up on the LinkedIn groups. If you're not a member of that, please hurry over to that and we will put you in this so we can have our own discussions on anything on DBA fundamentals you like. With that, we also go to our first sponsor, SentryOne, who has some of the greatest software I've seen for working with, especially on query tuning and a number of other great things like that. I do love Plan Explorer. I have used it quite frequently here lately to get better performance from any SQL. I use it a lot. They also have other great tools as well that are very helpful and you can learn a lot from, and as always, they're willing to help. You can always go to answers.sqlperformance.com to get free query tuning advice, as well as century1.com/resources for any helpful resources from SentryOne itself. With that, we'll go to our next sponsor, DBWatch, where they have also great monitoring tools. They do some performance tuning. They do a lot of for security and losses management and database administration. What's one of the great things that I've actually seen about DBWatch, and I've actually used it a few times here lately, is because they one of their big things that their main tool does is actually it allows you to go between SQL Server and Oracle, or Postgres, and MySQL. That's the main ones that I use here at my company. You can actually use the same tool to go between all of it, and that is very nice for me because for years I've had to go between multiple different tools. So this one works rather well for me, at least. Please give it a try. See what you think and let them know, because they're always looking for more great feedback. These here on the screen now are all of our virtual groups that PASS has. You'll notice there are lots of things in the application development, in business analytics, data science itself, obviously DBA fundamentals and database administration, in professional development, and one of my favorite tools here lately, PowerShell. There's also the other for different languages, such as Chinese, Hebrew, and Italian. Also one that actually covers a number of people and is actually kind of dear to my heart is a women technology group, where it actually focuses on different women in technology, and they're all presentations about women. And it gives them a forum to actually talk about helping other women, or to actually bringing other women up in technology. Truly, I do support them any way I can with any of their pushes. Also, here's upcoming SQL Saturdays. I will actually be at the Nashville SQL Saturday here on January 18th. But please go to any of these that are near and dear to your heart, or near where you're going to be around their area. If you can vacation in an area where there is going to be SQL Saturday, please do so. I know me and many of my friends actually go to different places around the country where there are SQL Saturdays, just to either volunteer, help out, or learn. It's a great way to spend a Saturday, or actually spend a vacation. Just lump it in there with great things in the areas themselves. That's what me and my friends tend to do. Yeah, we're different. Why not? We love SQL Saturday that much. And with that, I do thank you all very much. So have a great day and a great week, and I will talk to y'all next time.